So welcome to today's video, and I'm going to talk about the aggregate production function in macroeconomics in today's video. In macro's model or macro's paper, we can very often see that the aggregate production function is given in this form. Y equal A K alpha L1 minus alpha. Y is the total output, and A is the TFP, total factor productivity. K is the capital, and L is the last factors of production labor. Of course, we can also add H, human capital, in this function, but for simplicity and for illustration, let's just take this form of aggregate production function. So before moving on, I shall talk about some features of this production function. First of all, what is so apparent is that since this is alpha and 1 minus alpha, this aggregate production function is exhibiting constant return to scale. Constant return to scale means that if we say increase the input of capital by two times, and if we increase the input of labor by 2 times, then the output will also increase by 2 times. This is constant return to scale. Other than that, the second point is that by assuming this Cobb-Douglas form of production function, the presumption is that the elasticity of substitution between capital and labor is 1, which means that these two factors of production is fairly substitutable, which usually applies in the real-world scenario. So everything seems making sense to this point. But let me interrupt and ask you a question. Have you ever thought about why can we use such a simple production function to represent the whole complex and complicated economy? Does this production function make sense at all? The answer is yes and no. But yes, under some special scenario, yes, this form of aggregate production function does make sense. But if we impose more strict or tightened assumptions, then this form may not be the most suitable one for us to do any prediction or to be put in any models. So now let me go over how can we make sense of this aggregate production function proposed by Solow. Well, so now let's put ourselves in the shoes of one of the many identical firms in a perfect competition market. So now the market is perfect competitive, and the goods produced is homogeneous. That means the goods produced by different companies is substitutable. It should be perfect substitutable. That means we use the same technology to produce the good. So now, for an individual firm I, our production function looks like this. Yi equal Ai. Also, for simplicity, let's disregard capital in this case, and we only use Li labor as the input. Since we use same technology, so the share of labor should be the same, so that A doesn't vary with different company, and A is a constant. Then now let's consider the competitive equilibrium. So for any firms, the objective is to maximize the profit. So let's write down the profit function. Pi I equal AILI1 minus wage. This is taken as given because this is perfect competition. Okay, so now let's take first order condition. We can get this 1 minus alpha AI Li minus alpha minus wage equals 0. Then we can rearrange the terms and we can get this. Further rearranging, we get this. Let's make the alpha positive, which means switching the terms. So we get this. Finally, we get this. So we can see all this term here is constant. Then this is the only variable, AI, the TFP. So that means the relationship between labor for firm I and the TFP for firm I is indirect variation. Or simply we can thought it in this way. We can think this is a one-to-one relationship. Okay. Then let's think about it in a broader sense right now. In the whole economy, so this is the fact, right? If we add all the labors in all the firms, we get the total labor in the economy. So exploiting this fact, if we move it to the left-hand side, we can do something like this. Since Li is only AI as we have talked about, then the relationship become like this. Then 1 and finally less times labor per firm into both sides. So we get Li, the labor employed by each firm, and the total labor is in proportion. So they're proportional. This is the relationship we wanted to verify the Solow aggregate position function. Okay. With this proportion derived, we can now take a look at the initial aggregate production function for each firm I. This is the initial aggregate production function we know for each firm I. Now we can substitute this Li back into this aggregate production function. Let's see what will happen. So Yi equal I. So for this case, since every firm is identical, and this is a competitive market, perfect competitive market, the total output in the economy is just simply the summation of all outputs of every firm. But bear in mind that this is a special case. This aggregator does not apply to all scenarios. Say, if we have heterogeneous products, which means every firm adopt different technologies, then this simple aggregator doesn't work anymore. So this is only a very, very simple case for illustration purpose. But anyways, we can now use this aggregator. Then Y, the total output in this economy equals okay. So now we'll have to simplify this mess in the middle. So let's take a look at these two terms first. First of all, times the power inside to the brackets, we get multiplying this into the brackets, we get 1 minus alpha. Then this is its power is 1, right? If we multiply this to this is equivalent to this. Then what we get is 1 minus alpha plus alpha. 1 minus alpha. Okay. Problem solved. Then so that this mass become the aggregate of divided by to the power 1 minus alpha, L1 minus alpha. We can see that basically these two terms are identical. So its power is 1. So by division rule or division, what we get is this. Summation of I 1 to the power 1 minus 1 plus alpha. So this is what we get at last. So right now, if you were given this simple form of aggregate production function, you should know what this A means now. This A, being the total factor productivity, is actually each firm's total factor productivity to the power 1 over alpha, the summation of this to the power alpha. This is what meant by this alpha. So this is one way how we can micro-found this seemingly fake aggregate production function. Actually, this does make sense. The A doesn't come from nowhere, but we can calculate it by this way. But do remember that why we can use this simple aggregator is because here we assume that the technology is same and the goods produced is homogeneous and the market is perfectly competitive. Some may also ask that whether this solution is Pareto optimal. The answer is yes. We can just simply prove that by invoking the first welfare theorem. But we can also put ourselves as the social planner. Then the problem for us will be maximized. Choosing Li, summation of all thing. This is the Lagrangian multiplier, and this is actually the Lagrangian we get. So the constraint social planner phase is the labor constraint, and we maximize the total Y subject to the labor constraint. If we take first order condition, then you can get something similar to this. The only difference is that the constant here is no longer wage, but the Lagrangian multiplier. And henceforward, you can also get this relationship, and you can replicate this process and get this proportion and substitute this back in the aggregate production function for each firm to get the same result. So I think that's pretty much today. This is all I want to talk about in today's video. So I hope that you understand that the aggregate production function is not groundless. It can be derived using microeconomics knowledge. In future videos, I may talk about, for some more complex assumption, how can we micro-found the aggregate production function, and what is missing in this aggregate production function proposed by Solow hundreds of years ago. But anyway, wishing you a healthy day, good day, and I will see you in the next video. Peace.